Okay, and this is my last video lesson for you all your year 12s. I have very much enjoyed making these videos, and I wish you all a lovely summer holiday. Please look at Show My Homework for some revision tasks that I'm going to give you. But obviously the most important thing is that you do rest and recuperate. And look forward to seeing you in September. So the last video lesson, I'm going to finish off chapter 3 today, okay, on recurrence relations. There is an exercise. I'm going to do 3G and 3H today. I'm not going to do a video lesson for 3I because the modelling is quite difficult. We will do that when we come back to school. So I'm going to leave the modelling. Okay, so recurrence relations, chapter 3. What is a recurrence relation? Well, you have seen this in GCSE. In GCSE it was called iteration or iterative methods. Now, what you can see is that, if I explain this, you're told that to find the n+1th term, that's what this means, you do 4 times the term before the nth term plus 1. So this is 4 times the term before plus 1 gives you the next term. The n+1 term is the term after the nth term. And you always need to be told what the first term is. If you're not told the first term, you can't work out the second, the third, etc., the fourth terms. So if I asked you to find, using this recurrence relationship, if I asked you to find the second term, what you do 4 times the first term plus 1. You're told the first term is 1, so you've got 4 times 1 plus 1. So you're replacing U1 with 1. So you get 5. Okay, so we know the second term now. If you wanted to find the third term, go back to your recurrence relationship. It's 4 times the term before plus 1. The 4 and the 1, you can see they're not changing. It's only the term itself that's changing. So it's 4 times the second term plus 1. So you get 21. Okay, you all work out the fourth term now to make sure you understand this recurrence relationship. Well done. We get this. So we get 4 lots of 21, add 1, so that is 85. So these are the terms of the sequence that I get. 1, 5, 21, 85. I can see that it's not a geometric progression and it's not an arithmetic progression. It's just a sequence of numbers. Okay, so what I want you to do yourself now, pause the video please. Okay, can you try this one? Using this recurrence relationship, the first term is 4. Can you find the second, third and fourth term? Okay, let's see how you did on that after you pause the video. Okay, so the second term is 2 lots of the first term, take away 1. So that's 5. The third term is 2 lots of the second term minus 3. So that's 7. The fourth term is 2 lots of the third term minus 3. So that's 11. Okay, is this a relationship? It's gone up. So this is the sequence of numbers I get. 4, 5, 7, 11. Goes up 1, goes up 3, goes up 4. Not really a sequence either. An arithmetic or a geometric sequence. Okay, so please spot my deliberate mistakes and send me my deliberate mistakes. First people to spot them get prizes. Okay, I'm going to see you in September. Right, so let's look at an example. This is one taken from the book. It's on page 20. Sorry, example 20 on page 79. Okay, so I'm going to go through this example. If you want to go ahead and try it and then just check the answers, then you can fast forward if you're getting it all right. Okay, so I've got a sequence of numbers, A1, A2, A3. I'm told the first value is P, and P must be negative because it's less than 0. And here's my recurrence relationship to get my other values. And the first thing you're asked to show is this formula here, this connection. Okay, so I think what I'm going to do is I'm going to find the second term, okay? Because I can't find the third term before I got the second term. So the second term is the first term squared minus 1. I know the first term is P. So I get that. Right, now I'm going to find the third term. Now the third term is the second term squared minus 1. Just using this recurrence relationship here. Right, the second term is P squared minus 1. I'm squaring it and I take away 1. So now I'm going to multiply out P squared minus 1. Okay, so just a bit of subworking now. Okay, P squared minus 1 times P squared minus 1. Do not fall into the mistake of saying this, a common mistake. Do not say this, please. Do not just square the first and square the second. I have seen this so many times. It is wrong. You have to do P squared times P squared. P squared times negative 1. So I've done this and then minus P squared and then plus 1. So this is what I get. So that's just your algebra. Okay? Right, so let's put that back into my expression. And then I'm going to take away 1. So the 1's will cancel and I've got back to what I need. Okay, fantastic. Right, part B of this question asks you to find the value of P if you're told A2, not A1, you're told A2 is 0. Right, okay, so I know the formula for A2 is P squared minus 1. So I know this, and I know I'm told it's equal to 0. Okay, so therefore if I add 1 to both sides, I get this, and P will equal the square root of 1, which is plus or minus 1. You're also told at the start that P is less than 0, so P must be negative 1. So there's my answer. Okay, part C of the question asks you to do this. Find, remember this means the sum of all my terms from 1 to 200. Right, well, let's just see what we get. Let's just look at this sequence and see what these numbers are, what kind of sequence it's making. Right, so I'm going to look at A0, A1, A2, A3, plus I want to go all the way to my 200th term. That's what I'm trying to find. Right, what is A0? Well, A0, sorry, I don't need A0, that's a mistake. It starts at A1. Okay, so A1, because R starts at 1, not 0. Be careful here. Okay, sometimes it does start at 0, so just be careful. So A1 is P. Yeah, so A1 is P, and P is minus 1. Okay, we know that A2 is 0. Okay, so let's find out what A3 is. Well, I've worked out a formula for A3. Okay, it's well, actually, I know this, don't I? I'm going to go back to the recurrence relationship rather than using the formula. So I know A2 is 0, so if I put 0 in, 0 minus 1, it gives me minus 1. Okay, so what will A4 be? A4 will equal A3 squared minus 1. What's A3? A3 is minus 1. So minus 1 squared minus 1 will equal 1 minus 1, which is 0. So you can see what is happening. This is oscillating minus 1, 0, minus 1, 0, minus 1, 0. Now we'll talk about what type of sequence this is later on. It's called a periodic sequence, but I go into more depth on that later. So this is what I get here. Now I've got 200 terms. How many negative ones have I got and how many zeros have I got? Well, I've got 100 lots of negative ones and 100 lots of zeros, because altogether I've got 200 terms. So half of them will be negative ones and half of them will be zeros. So I've got 100 lots of negative ones and 100 lots of zeros. And I'm asked to find the sum of all of these values. So I've got 100 lots of negative ones, that will equal negative 100. 100 lots of zeros, that will equal 0 if I add them all up together. So what will my total be? My total will be negative 100. Okay. Play that back to yourself again. If you're not sure, send me a comment, please, and I can give you another example on this. Okay, so last question. Find the 191st term. This is what this means. The 191st term. Well, let's go back to the sequence, okay? So we get this, minus 1, 0, minus 1, 0, minus 1, 0. It goes on forever. Now, I know that the first term, the third term, the fifth term are all negative 1. So the odd terms, first, third, fifth, the odd terms are negative 1. The even terms, my second term, my fourth term, my sixth term, my even terms are 0. So this is an odd term, okay, so that will equal negative 1. A really good question that, okay, difficult, so play it back to yourself if you need more support on that. Right, I'm going to go now into different types of sequences. Okay, now that was exercise 3G. It's a short exercise, okay, not much information I needed to give you on that. So I'm going to combine 3G and 3H together in this video. Okay, so definitions. What's an increasing sequence? An increasing sequence is just numbers that go up. So the next term is always bigger than the term before. Write these definitions down, please. A decreasing sequence is the opposite. It goes down. So the term afterwards is less than the term before. And a periodic sequence, okay? If the terms repeat in a cycle, you have a periodic sequence. The last example I showed you was a periodic sequence. Here's another example. Okay, so the numbers are repeating. Now, we say that the order of this periodic sequence is, in this case, it's 2, okay? So the order is 2 because it's repeating every 2 terms. So if it was repeating every 3 terms, for example, if I had this, minus 3, 0, 1, minus 3, 0, 1, minus 3, 0, 1, etc., the order of this sequence would be 3. Okay? Right. So some definitions for you to write down. Right, so let's look now at a couple of examples. I'm going to look at question 5 on page 82. Okay, this is question 5 on page 82 from exercise 3H. Okay, a sequence has nth term an equals this. And you want to find the order of the sequence. So, okay, so to find the order of this sequence, what I'm going to do is find each of the terms. So A1 is cos 90 times 1. A2 is cos 90 times 2. A3 is cos 90 times 3, because I'm just changing n here. And A4 is cos 90 times 4. I'm going to stop there. Okay, the reason why is if you think of your cos graph, okay, if you look at your cos graph here, okay, so I've got cos 90 is 0, cos 180 is minus 1, cos 270 is 0, cos 360 is 1, and then you can see it's going to repeat again. So I can see that after every 4 terms is going to repeat. So the order of this sequence will be 4. Okay, next, so I'm just going to write down that sequence here. 0, minus 1, 0, 1. 0, minus 1, 0, 1. Okay, now the next bit. This is some good thinking going on here. So have a go and see if you can do it yourself before I go through it. It's asking you to find the sum of the first 444 terms of this sequence. Now, they've chosen 444, not by mistake, but because 444 is divisible by 4. So if you've got 444 terms, you've got this sequence here repeating 111 times, a quarter 444. So now the total of all of this in here is going to just be 0, yeah, because it all cancels out. So you've got 0 111 times. So the answer is just 0. Okay, next question, another difficult one. This is my last question. This is question 4 on page 82. There is a mistake in the question. Q is 10, not 13, guys. Okay? So, you've got your recurrence relationship here. You're told U1 and you're told Q is 10. So if I look at U2, okay, U2 will be P lots of U1 plus 10 because Q is 10. To be honest, I don't know why they don't just put plus 10 there. That doesn't change. Okay, remember that was a mistake in the book. It's 10, not 13. Okay. So, I know that U1 is 5, so I've got my second term. Right, you're told that the order of this sequence is 2. So, I've got my first term is 5, my second term is 5p plus 10. And that keeps on repeating itself all the way across. So, these are going to repeat because it's got a period of 2. So, my third value, my fourth value, my fifth value, my sixth value. So these 2 terms keep on repeating all the way through. Now you're asked to find P. Well, the only way I'm going to find P is if I set the third term to be equal to 5. So let's look at what the third term would be. So I know the third term is P times the term before plus 10. I know the term before is that. And I know that U3 is 5. So now I've set myself up an equation. So let's multiply this out. I'm going to find I get a quadratic, which I'm now going to solve. And I'm sure you can all solve this without me going through it. So what you get is if I divide, the best thing here is divide everything through by 5. Yes, it will factorise. P plus 1. Sorry, that's 2. Sorry, that's 10. That's 2. And P plus 2. There's something gone wrong. I've made a mistake. Hopefully you've seen that. Let me go through it again. Okay, so multiply out. It's 10p. That was my mistake. I was going too quickly. Don't do that, please. Take 5 away from both sides. Divide everything through by p. And now it's going to factorise. Yippee Johnsons. There we go. So p is -1. And hence I've done my question. Apologies for that mistake. Okay. Gary, the door. Right, so your turn. This is what I'd like you to do from 3G and 3H, please. Just make that a little bit bigger. There we go, guys. 3G and 3H. And that's the last bit of work I am setting. Well done. Round of applause, everyone, for your fantastic hard work. I am so very, 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 very proud of you all. I'm really looking for... Loved seeing you all this week in school, and I hope you all have a fantastic summer, and I can't wait for September.